Hey, calculus folks. Thanks for watching my video and setting up your notes. These are called focus notes. They've done a lot of research on, what do successful students do? And one of the things they do is uh, not only record notes, but they go back and revisit their notes. Okay, so we're going to try to do that some, and practice that skill. And so first, let's get some notes down. I want you to make them your own. Like if I say something, you could write a little question out to the side, like what the heck is he talking about? Let me give you an example. Let's say you saw 5 to the negative 1 power. Okay. Now, if you didn't pause the video there just a little bit ago to get these all copied down, I want you to go back and pause the video so that you're not trying to copy and listen at the same time. Okay. So what is 5 to the negative 1? It's the same thing as 1 over 5, right? So like if you see a negative exponent, that's telling us that this quantity right here belongs down in the denominator. So we're going to put the 5 down there. Now, what if you saw something already in the denominator? Like let's say you saw the fraction 1/7. Okay. Could that be written as 7 to the negative 1? Yeah, you could just reverse, what I just did over there. I hope you don't feel like I'm insulting your intelligence there, but I'm going to take advantage of this idea right here, that if you saw something in the denominator, you could move it to the numerator. You could write it with a negative 1 power. Okay. So this is not our main topic, is negative exponents. Our main topic is rational functions. And back in section 1, they gave us a rational function. What is a rational function? It's a fraction that has a function in the numerator and a function in the denominator. So if I put up here 2, let's see, I want to get the exact one they had. They had 3 cosine of x. They had 3 cosine of x like this. And then they had 2 sine x in the denominator. So 2 sine x down here. When you see this, and you're trying to take the derivative, right? I mean, that's our goal. Our goal is to get f prime of x, right? Well, it's a quotient. And so what section 1 wanted us to do is investigate a little bit. So here I am. I've got 3 cosine x, 2 sine x. I have the numerical derivative calculated. Here it is in blue. See, the blue is the numerical derivative. Now, they kind of led us in this direction. They said, hey, why don't you just take the derivative numerator, derivative denominator individually? So they look so much like our original function, but confirm, like the derivative of cosine is negative sine, right? That's why it's negative 3 sine x. And the derivative of sine is just plain cosine. So we got 2 cosine x in the denominator. This is not the correct derivative. Let me verify that for you. See, the green function is not landing on that blue function down there, right? So I love the fact that you guys are testing that out on your own, and you're getting used to this idea that, that's our goal. We're trying to get a function down here. And I hope it's really making it clear right now that we don't have the correct function, right? So let's go back and investigate a little bit. Could I take advantage, before I come up with the derivative, could I take advantage of this negative power idea? So let me just rewrite f of x, okay, as this: 3 cosine of x times 2 sine x to the negative 1 power. That seems legal to me, right? I mean, if I raise something to the negative 1 power, it means this stuff belongs in the denominator, right? Now what I'm going to do is I'm going to do a product rule on this. I'm going to take 3 cosine of x, and I'm going to multiply it by the derivative of this chain rule problem. Let's think about that for a second. I've got an outer function up here, the negative 1. Let me put a little like red bubble around this and say that's my layer 1 out there. Then I've got an inner function in here. That's my layer 2, right? So let me bring the negative 1 down here, okay? And then I'm going to leave the inner function alone, 2 sine x, and then I'm going to reduce the power by 1. So that's now negative 2, right? Then I have plus, because the product rule works like this. Oh, wait a minute. I haven't done my layer 2 yet. Oh my goodness, I got ahead of myself. So then I multiply this stuff by the derivative of the inner function here. So that's 2 cosine of x, right? So this is my layer 2. Oh, let me switch back to red here for a second. This is my layer 2's derivative, and this is my layer 1's derivative right up here, kind of. There's like 2 parts of that. Man, I hope I'm making that clear. Now the product rule, okay? So I recopy the second function, don't do anything to it. So that's 2 sine x to the negative 1 power, right? And I'm going to multiply that by the derivative of the first function, which is just negative 3 sine x. Hey, I know, well, I'm pretty sure that this is the derivative right here. I'm tempted to go over here and just type it in, get rid of this. Well, let's just get rid of that. We know that's not the right thing, right? I'm tempted to type it in right now, but man, that would be a mess to type in. So let's see if we can simplify it a little bit, okay? Well, the 3 times the 2 would give me a 6. Oh, and there's a negative 1 right there. So that's negative 6. Oh, and there's another. Oh, I can't do that. I got to be careful. This 2 is in the denominator. It's going down the denominator, right? So you got to be careful there. So, but I could go 3 times negative 1 is negative 3 times 2 is negative 6. Okay, so I got negative 6. And then I've got a cosine for sure, right? I got a cosine function. And then I've got another cosine over here, don't I? So I could make that a cosine squared right there. Now that's all over sine 2 sine x squared, right? Because the negative exponent says, hey, that belongs in the denominator. Then I got plus, what do I got over here? I got a 2 sine x in the denominator because of that negative power. And then I got a negative 3 sine x up in the numerator. Negative 3 sine x in the numerator. Well, that's still awkward to type into Desmos. So let's see if we can simplify it a little bit more. Do you notice I have one factor of sine x here, but I got 2 factors of sine x over here? So let's see if we can get them to have the same denominators. If I multiply this one by another factor of 2 sine x over here, I would get negative 6 cosine squared x sine x. Oh, I need a 2 there, don't I? And then I'm going to have that all over. Wait, I'm going to make a huge fraction bar and just put the denominator down one time. So I got 2 sine x squared. Okay, so now they would have the same denominators. Son of a biscuit. I don't want to remake my whole video here. What am I doing, Nelson? Come on, man. Get your act together. Let me try again. I need this one to have another factor of sine x, right? 2 sine x. So let's back that off. If I multiply this guy right here by 2 sine x, and I multiply this one by 2 sine x, oh my goodness. I'm going to have a big fraction bar, and I'm going to have 2 sine x squared, right? And then up in the numerator, I'm going to have negative 6 cosine squared x. And then what do we have over here? We have negative 6 sine squared. Well, that's interesting. Huh. Well, this is maybe going to be difficult for us to see that how, because, look, I don't want to do this every time. I don't want to write a negative 1 power, and because this is a lot of work to do. So what I'm going to do is I'm going to tell you what the quotient rule is, and we're going to verify that we got the correct answer right here, okay? So let's put this down. You're going to have a function where you have a function up in the numerator divided by a function in the denominator. And the quotient rule goes like this. I'm going to put an arrow because what I'm about ready to write is not equal to this. It's the derivative. So the derivative is very different than the original function, right? So you go, I'm going to give you the little saying, low d high. That means you take the denominator and multiply it by the derivative of the numerator. So you go v times u prime. Then you go minus high d low minus u times v prime. It's all over the denominator squared, okay? It's all over the denominator squared. So the saying really goes low d high minus high d low, square the denominator, and away we go. But we'll get better at saying the saying. Anyways, I come back up here, and let's try it right now. I go low d high, so that's 2 sine x times the derivative of the numerator would be negative 3 cosine x. Then, I did it again. I got to wake up here. The derivative of the numerator is negative 3 sine x, right? Derivative of cosine is negative sine. That's where I had the negative, but I just wrote cosine. Sorry. Minus high d low. So I'm going to go 3 cosine x high. You just write down the numerator times d low means the derivative of the denominator. So I'm going to go 2 cosine x. Okay. And then it's all over the denominator squared. So it's all over 2 sine x quantity squared, right? See, I've got the denominator. Do I have the numerator up here? I do. It's just in a slightly different order. You notice like sine times sine would be sine squared, check mark. Cosine times cosine would be cosine squared, check mark. And they both have negatives with them, right? So, you got the negative there, which is 6, that -6, and then you got 2 times -3 is -6. So it's definitely the same thing, right? So let's put that into Desmos and see if it really does match up, okay? So over here, we're going to have a fraction, and we're going to have -6 cosine of x squared, okay? And that always makes me nervous. Like, is it the x being squared or is it the cosine? I want the cosine being squared. So I'm going to put parentheses in here so that it's definitely going to square the cosine, right? So let's look back one more time, right? We had -6 cosine squared x minus 6 sine squared x. So now I need to have a -6 sine squared x right up here. -6 sine. I want to put a parenthesis in there. Sine. Oh man, sine of x squared. And then down the denominator, we have 2 sine x squared, right? All right, let's turn it on. Drum roll, everybody. Ta-da! Look at that. It matches up perfectly. Oh my gosh. Look at that, right on those crazy little shapes down there. So you got to be super careful, don't you? That you're really focused and more focused than I was just focused there when I was, taking low d high minus high d low, square the denominator, and away we go. So you just take the denominator, you square that, right? And then you're going to do the low d high minus high d low up in the numerator. So let's try a problem. Let's try a practice problem. And let's do the first homework problem together, okay? So I'm turning the book to section 3 right now, and the first homework problem looks like this: x cubed over sine x. So I'm on page 139, and it's number 1 that I want to put right over here. And it's kind of a, maybe a more straightforward one because it's got a power rule up in the numerator, x cubed, and it's got a trig function down the denominator, sine x. So when I do the derivative, I'm going to go low d high. So it's sine of x times 3x squared minus high d low. So high, I write down the numerator. D low, I take the derivative of the denominator, cosine of x. Then I put that all over the denominator squared. So sometimes we write sine of x squared with the squared part on the n. It means the sine of x squared, right? This is probably the answer that's in the answer key online or in the back of the book, all right? I don't see any, massive simplification we could do. He might divide out or factor out an x squared term and write it like this: x squared times 3 sine x. Let's see, what else could we do here? I think that's it right there. Minus x. Oh, wait, I want a parenthesis here. And then I would have x cosine of x over there. And all of that stuff is going to be over sine squared x. Okay? So, this parenthesis maybe right here we don't need, I suppose. And this one over here I could probably get rid of. And I think, either he's going to have that answer over there or this answer over here. I'm just factoring out an x squared factor. Man, I hope I'm making the quotient rule clear to you. If I'm not, please call me over. And I hope my mistake over there wasn't too distracting when you were taking your notes. So thanks for following along, everybody. I'm here to help you out.